Well, it's time to wrap up our equations unit, and in this final video we're going to be looking at how to apply all of that knowledge to some practical problems. As a teacher, I get asked many times, when are we ever going to use this? Well, today we're going to put it into practice. Although knowing how to solve equations is useful, it's even more important to know when and how to apply these skills to solve real life situations. So for example, we could be asked to find the total cost of hiring a taxi or even a tradie like a plumber or an electrician. We could be calculating the cost of a particular item. We could be finding the age of a person in a worded puzzle. Or we could be finding the missing side length or even the angle of a shape. All of these are types of problems which can be simply solved if we can apply our knowledge of solving equations. Alright, we're going to start by looking at an example, and this particular example involves hiring a tuk-tuk. Now a tuk-tuk is a type of taxi, there's a picture of it there on the right, which you can hire when you're in Thailand, which is pretty relevant for me at the moment because I'm just about to head off on the Year 9 Thailand trip, hence I'm making all these videos. Alright, let's look at the problem. The cost of hiring a tuk-tuk in Thailand is 50 baht, and baht is their currency. And that 50 baht is what we call a flag fall. In other words, it's the amount that they charge to pull over and basically let you get onto the tuk-tuk. And then on top of that, they charge you another 12 baht for each and every kilometre that I travel. Now my journey from the market, where I've done lots of shopping, surprise, surprise, to my hotel is 23 kilometres. If I've got 290 baht left, the question is, do I have enough money to get me home? Now we're going to be looking at how we can best set this out so that we can communicate our ideas and show how we came up with an answer. Okay, so for all of the problems you're going to be looking at of this variety, we're going to follow these same 5 steps. Firstly, we're going to define the variables, and that means that I'm going to choose some letters which represent the things in my problem which could possibly be changing. So in our tuk-tuk problem, it could be the cost that's varying, and it could be the number of kilometres I travel that varies. Secondly, we're going to have a go at writing an equation that describes this problem. Thirdly, we're going to solve the equation, and we're going to do that by using all of the algebraic skills that we've been developing so far by substituting any values which we do know and working out the value of the remaining variable. The fourth step is to go back and read the question, make sure that what you've answered is actually answering the original question and making sure that you've included the correct units. In this question, it will be all about baht. And a worded question requires a worded response, so a final sentence which states what you found. Alright, so let's apply that to our tuk-tuk in Thailand question. Let's remind ourselves of what this question was all about. The cost of hiring a tuk-tuk in Thailand is 50 baht, which is the flag fall, plus 12 baht for every kilometre I travel. My journey from the market to my hotel is 23 kilometres, and if I have 290 baht left, do I have enough money to get me home? So let's see what the process is. Firstly, I need to define the variables, decide which things are varying and what would be a suitable letter to stand for those. So I've decided to let C be the total cost of the ride, and that of course that answer would be in baht. And I've decided to let K stand for the distance that I travel in kilometres. Okay, next step, I need to write an equation to describe this problem. So that involves me going back up to the original question. We know that we've got some values here which are pretty important. 50 baht, 50 plus 12 baht for every kilometre that I travel. So what does that mean? If I travel 1 kilometre, I've got to add on one lot of 12. If I travel 10 kilometres, I would have to add on 10 lots of 12. Now, given that I've decided to let the distance that I travel be represented by k, then a possible way of setting out my equation could be this. C, or the cost in baht, is equal to the 50, which was the flag for, plus 12 baht for every kilometre that I travel. Okay, so there's my equation that I've decided to set up, and I have defined my variables. The next step is to solve that equation using my algebraic skills by substituting anything that I do know and working out the value of what's left. So at this stage, what do I know? I know that I have 290 baht. So I have a cost that I know that I can run to, which is 290 baht. Anything more than that, and the taxi driver is going to drop me off somewhere not at my hotel. So let's put this in to where this cost is. So I'm substituting for C. I'm substituting in 290. I know I have to pay the 50 baht flag for, and I know that I've got 12 baht to pay for every kilometre, but I don't know whether I'm going to have enough money to cover the kilometres. So I want to work out how many kilometres this will get me, this 290 baht. So this is an equation that we have solved many of before. The variable that I'm trying to find out is the k, so I need the k on its own, and I'm going to do that by, of course, taking away 50 from both sides. And if you want to write down those arrows, well, of course you can. Some people are probably over that by now. Now I'm going to divide both sides by 12, because the opposite of timesing k by 12 is dividing by 12. So I'm just going to write it like this. And I find out that k is equal to 20. Now I guess I need to decide, have I answered the original question yet? So what is this 20 all about? Well, have a think about it. I've got 290 baht, and for that 290 baht I can travel 20 kilometres. Is this the answer to the question? Well, the question is, do I have enough money to get me home? My home was 23 kilometres away. I've only got enough baht to get me 20 kilometres. So now what I have to say is that I will not have enough money to get me back to the hotel. In fact, I'd be dropped off 3 kilometres away from the hotel. Not ideal, considering I'm probably carrying quite a few bags of all those bargains that I've bought. Okay, so there's a process for solving our tuk-tuk problem. Let's have a look at a different one now. Very different. John and his elder sister, Katie, are 7 years apart in their ages. If the sum of their ages is 39, find Katie's age. Okay, so just as a reminder, over on the left-hand side here, these are the steps that we need to work through. So I need to define the variables which I'm choosing to stand for these unknown numbers. So first of all, I've got to get my head around what it is that I have to find. So I'm going to read the question again. John and his elder sister Katie are 7 years apart in their ages. The sum of their ages is 39. Find Katie's age. There's my clue. Find Katie's age. So whatever I find along the way, at the end result has got to be me finding out Katie's age. So for that reason, I'm going to focus on her age. At the moment, it might be that I decide to let Katie's age be represented by K. Sounds straightforward. What about John's age up here? Now I know some of you are probably saying, oh well, let's just let John's age be J. What would I have then? I would have J, John's age, plus K, Katie's age, adding together to be 39. And there's not a problem with that. However, we haven't included this idea that their ages are 7 years apart, and that's going to be crucial in us finding what their individual ages are, and of course what Katie's age is in particular. So I need to somehow use that idea included in my equation so that I don't get an answer like 38 and 1, okay, because they're not 7 years apart. Alright, so this is what I've decided on. I'm going to let Katie's age be represented by K years, and I'm going to let John's age be represented by K take away 7 years. Now have a think about how I've got that. John and his elder sister Katie. So Katie is 7 years older, which means John is 7 years younger. So he is Katie's age, take away 7. Now I've got both ages written in terms of one variable, and that's K. So maybe I can work with those now to create an equation. So I'm going to go back to this idea here. The sum of their ages is 39. So I've got Katie's age, and then I've got John's age, which is K minus 7. I have to sum those together, which looks like this. So Katie's age plus John's age is equal to 39. That's probably the hardest part of this whole process, is getting the equation right. Once I've got the equation right, it's pretty smooth sailing from here. So we've written an equation. Maybe I'll even think about simplifying it. K plus K, surely I could write that as 2K. And now I need to work towards getting each equivalent equation a little bit simpler than the one before. So I'm going to undo this minus 7 by plussing 7 to both sides. And then of course I'm going to undo the timesing by 2 by dividing by 2 to find out that K is equal to 23. I need to go back and make sure that I've answered the question. I set it up in such a way so that I would actually be finding Katie's age, and that's why I focused on Katie's age and called it K. So yes, Katie's age is 23. Just out of interest, what would that make John's age? Well, John's age would be 23. Take away 7, which would be 16. And I could check, does 16 plus 23 equal 39? You bet it does, so I know my answer's right. Last step, a worded question requires a worded response, so Katie is 23 years old. And there you have it. 5 steps towards solving those worded everyday problems. Gotta love that. Alright, your turn. You've watched it. You've written some things down. You've got those 5 key steps hopefully already written down. Remember, just a brief summary is always a good idea to wrap up what you've learned and what were the key ideas. And of course, jot down those questions for anything that you're not sure about. Bring them into your next maths class. Okay, have fun. See you next time.